Alright, here's some more EOC review, starting some trigonometry. Trigonometry, it's just important that you understand opposite, hypotenuse, and adjacent, and you understand the trigonometric identities as far as, or definitions, I guess, as far as sine, cosine, and tangent, and be able to identify which one is which. Okay, so let's get to it here. So here's give these diagrams below. Complete the following statements. The sine of 33.7 is equal to BC over, alright, so whenever there's sine or cosine, you're dealing in hypotenuse. Okay, so, and it's talking about sine, it's the opposite line segment, so it's BC. BC is opposite. I think I'm going to make opposite orange because of opposite. And hypotenuse, I'll make green. So hypotenuse is green from here on out. Okay, and orange is opposite. Okay, so this is the opposite, and this is the hypotenuse. So the hypotenuse is AB or BA. Okay, so sine is opposite of theta and divided by the adjacent. Okay, sine of 33.7 over here is DF is the hypotenuse, and that's on the bottom as it should be. And the opposite, if we're talking about sine is dealing in opposite, and that's DE. DE is opposite for orange. Okay, so that's DE. That's opposite. And the statement here is BC. BC is the opposite. That's the opposite over AC. AC is the adjacent. We'll call adjacent is. How many colors start with A? No. But I have B. So adjacent will be blue. AC, BC over AC, right? So this is the opposite over adjacent. ADJ is that is the tangent equals the tangent, and if you're comparing it to the other triangle, then it's going to be, it would then therefore be able to say is the is of theta, tangent of theta, which then in this case would be theta being 33.7, because the only angle we're dealing with here. It would then be BC, instead of the same relationship, would be DE over EF. So that's kind of how the whole thing goes there. Okay, that's the tangent. Alright, so that's that one. Moving on to this one. Company is requesting equilateral triangle tiles that may be a new office floor. So let's draw an equilateral triangle, meaning that all three line segments are the same length. I'm going to make them, I guess, an inch long, because that's what the ruler I grabbed. So that's one side. Let's see, I think that's one side here. That's one side, and then we got that's one side over here. And these are all the same angles, and these are all the same lengths. It's an equilateral triangle. If the height, so the height of this is 10.4 inches. So this is 10.4 inches. What is the length of one of the sides? Alright, so this is the length divided by 2. This is 90 degrees. These are 60 degrees, because 180 split evenly about 3 is 60 degrees. If that's if each one of those is 60, then this orange angle that I'm making right now is 30 degrees. So we have a 30, 60, 90 triangle. Okay? So there's lots of different ways you can figure this one out. So this leg here is what we're looking at right here. This is the opposite of that 30 degrees. And the hypotenuse here. Hypotenuse has been made. No, I shouldn't use green for this one. It's a bit confusing. This would have been the blue one, would have been the adjacent one. Yeah. So this would have been the adjacent one, which would have been 10.4 inches. Anyway, and then it's trying to figure out, hey, what is the length of this side? Right, you can use a 30, 60, 90 relationship if you want to. And the 30 to 60 relationship is the leg. This is the double the leg, and this is a square root of 3 times the leg. And you could do that going from here to here. That's a little bit sloppy math. I mean, you could go, this is, you know, the 10.4 divided by square root of 3, or you can just do trigonometry, which I think is better, right? So this is the, I'll show you two ways. This is the algebraic way first. Okay, the algebraic way first is I'm using, I gotta figure out what sides relative to theta. Okay, I'm going to use this theta because that's what I figured out first. That's 30 degrees. So relative to theta, I'm trying to figure out the hypotenuse. That's opposite the 90 degrees. That's not relative to theta at all. That's just the hypotenuse. Okay, the hypotenuse is the hypotenuse is the hypotenuse. It's relative to the 90 degree angle. The other one that I'm working with is this 104. Right? So I have the hypotenuse and I have the adjacent, because the hypotenuse and the adjacent join to surround theta. Okay, so, and I have theta. Okay, I have theta. I guess I have the angle theta, and so I can use sine here. I'm going to use sine. That's the quickest way. All right, so the sine of theta equals adjacent over hypotenuse. Okay, so to solve for the hypotenuse, I multiply both sides by hypotenuse, then divide by the sine of theta. So I get hypotenuse equals adjacent divided by the sine of theta. So that's going to be equal to 10.4 divided by inches divided by the sine of 30 degrees. Okay, so I do 10.4 divided by 30 sine, that's the sine of 30, so that means that this is 20.8. No, I did sine, oops, this is supposed to be cosine. Why did I do sine? I said cosine, right? Using what sine? Number two is what function? That is cosine. I said cosine in the front. I don't know why I wrote sine. This should be cosine. Sorry about that. Cosine, because it's opposite, or it's adjacent over hypotenuse. So anyway, it's 10.4 divided by 30 10.4 divided by 30 cosine, which equals 12. So this hypotenuse equals 12 inches. equals 12 inches. Okay, so that's the answer to that. So then there's the common sense way. This is the way I like it. All right, so I know that I know this angle, and I know that this is the adjacent, and I know I have to figure out the hypotenuse. Well, I know that the hypotenuse is always the longest leg of a triangle, and I know adjacent and hypotenuse is cosine. Okay, so in order to make 10.4 longer, and I know that cosine and sine are always less than 1. I need to divide cosine by the sine of, or by the cosine. I need to divide 10.5 divided by the cosine of 30. So let me say that again. That was a little messed up. Sorry. So I have a right triangle, and I have the adjacent side I'm working with, and I am trying to find the hypotenuse with the angle theta, right? Because the angle theta and the hypotenuse, because the adjacent, this side is join the hypotenuse to make theta, I know that this side is the adjacent angle. Anyway, so that means I need to use cosine to find this angle, this side length using this side length. So I know that this is going to be longer than that. My hypotenuse is going to be longer than that leg. So I need to, in order to make a bigger number using a smaller number, like the sine or the cosine of a degree of an angle, it's always going to be less than 1. I need to divide this value by that sine or cosine. All right, so I go 10.4 divided by the 30 cosine, and that's your answer. That's the common sense way to make it, which is what I like to use. All right, sorry about that. It's late on a Sunday evening. Okay, here we go. There's another one. Hanging streamers from a brother's surprise party. She's securing different lines of peak ceiling. Center floor is directly underneath, so that's a 90-degree angle. Ceiling, floor. Okay, the distance along the floor of the center room is 6 feet, so that's 6 feet. The second streamer is attached. Okay, same spot. The distance between is x feet. Okay, trying to figure that out. The distance between is y. So then we have a distance between the second streamers. So this is x feet, and then this would be y feet, I guess. Okay. The length of the, wait a second. The distance between the streamers is x feet, and the length of the second streamer is y feet. This is y feet. Y feet. All right, so we have an x feet, and we have a y feet. And we have a y feet, looks like the hypotenuse. The angle formed between the two streamers is theta. Select the equations that are true to the nearest tenth of the diagram. Okay, well, let's go to work here. So first, let's make this whole thing here identified as x plus 6 feet. That'll be that whole thing right there. Alright, so the sine of theta here. Alright, so this is theta. Make this. Let's make theta a different color. Let's make theta red. Alright, so that's theta. And opposite of theta is this line segment right here. This is the opposite line segment. We're using it opposite as orange. That's the opposite leg. Blue with theta. Blue is this leg. And is this angle congruent to that angle? No, those are not congruent angles. Because as this streamer approaches the line, that angle gets more and more steep. Okay. Alright, so the sine of 22. The sine of theta equals 22 divided by y. Where's this 22 coming from? Did I miss anything in here? They give me, well, first of all, let's all right, we can figure this angle out right away. This angle here is going to be I need a different color. Let's get a pink one out here. So this angle here is the adjacent divided by the hypotenuse of this one. So that's going to be the arc tangent. So this angle here, we'll call this, I don't know, we'll call that angle pink, like that, I guess. Angle pink is going to be adjacent over the opposite, so it's going to be the arc tangent. So the cosine of this angle is the adjacent over the hypotenuse. So the angle measure in degrees equals the arc cosine. Why is that wet? The arc cosine of the adjacent angle over the hypotenuse, which is equals 6 divided by 22.8, which equals, that's the arc cosine. So when I figure out the actual angle, I go like that. That angle is 74.7 degrees. So this angle is 74.7 degrees. Okay, so now if I want to figure out the actual height of this, I can actually even do that Pythagorean's theorem. So to figure out the actual height of this, I can just use Pythagorean's theorem, and I could also use trigonometry, but I'm going to use Pythagorean's theorem. That's going to be the hypotenuse on this one, which would be 22.8 squared minus 6 squared, and those are both feet. So 22.8 squared minus 6 squared equals, take the square root of that, and that's 22. That's where 22 comes from. So that's 20. This should be orange. This is 22 feet. All right, so we've pretty much figured out everything. Well, I can figure out what this whole thing is here. All right, so if I know that this is 22 feet, I don't know the second string number yet, though. Oh, my daughter's calling me. Hold on. And I'll get to this one another time. I have to go kill a spider for my daughter. So that's this one. That's it for tonight.